Have you ever wondered if we could predict a flood before it happens, or know a drought is coming long before the taps run dry? This isn't science fiction. It's the power of predictive hydrology. By combining real-time data, advanced simulations, and artificial intelligence, we can now anticipate water's every move. From forecasting floods and managing droughts to ensuring our city's pipes can handle the pressure, predictive hydrology allows us to proactively manage our most precious resource. So, how does it work? It all starts with data. Imagine a vast network of sensors spread across the landscape. Rain gauges measure every drop of precipitation, while other sensors monitor the depth of snowpack in the mountains. Along rivers and inside reservoirs, flow monitors track water levels and speeds. Even underground, sensors keep an eye on groundwater tables and soil moisture. This constant stream of information is the lifeblood of predictive hydrology, feeding into our models in real time and forming the backbone of every decision we make. But all that data is just numbers until artificial intelligence steps in. This is where the magic really happens. AI and machine learning algorithms sift through mountains of historical and real-time data, identifying complex patterns that would be invisible to the human eye. They run predictive simulations to see what might happen next, forecasting potential floods, anticipating sudden spikes in water demand, or warning of an impending drought. Based on these insights, automated alerts can be sent to water managers, guiding everything from reservoir releases to emergency response, dramatically cutting down reaction times and boosting our overall resilience. Let's talk about cities. With more concrete and fewer green spaces, urban areas are especially vulnerable to flooding. But predictive hydrology is changing the game. Its AI can analyze a city's layout and predict exactly where stormwater might overflow. These models help optimize the operation of pumping stations and retention basins, moving water to where it can be safely stored. In the most extreme scenarios, these simulations guide evacuation plans and help protect critical infrastructure like hospitals and power stations. By forecasting floods before they hit, we can minimize damage and, most importantly, save lives. On the flip side, what about when there's not enough water? Predictive hydrology is just as crucial for managing droughts. By analyzing weather patterns and consumption trends, these models can forecast when reservoir levels might drop or when groundwater is under stress. AI then helps recommend the best way to allocate the limited water we have among cities, farms, and natural ecosystems. This allows authorities to implement conservation strategies and water rationing proactively, not reactively. It's how communities can stay resilient even during long, dry spells. To make these predictions even more powerful, we integrate them with long-term climate models. This gives us a much bigger picture. We can predict how changing weather patterns, like more intense storms or longer heat waves, will impact our water resources over decades. This helps us assess the long-term risks to our dams, levees, and pipe networks. It's essential for guiding smart investments in new infrastructure and strengthening our emergency preparedness plans. This integrated approach is the key to sustainable water management in an uncertain climate future. And this isn't just theory, it's happening all over the world. Take Singapore, which uses AI to predict urban flash floods, keeping the city-state running smoothly. In California, sophisticated hydrological models are essential for managing reservoirs and planning irrigation to get through punishing droughts. And in the Netherlands, they combine advanced river basin modeling with smart infrastructure controls to masterfully manage high-flow events and protect their low-lying country. These real-world examples prove just how impactful predictive hydrology is. Looking ahead, the future is even more exciting. We're moving toward fully automated water systems that can instantly respond to AI predictions without human intervention. Imagine a city's water grid that adjusts itself in real time to prevent floods or conserve water. We'll see tighter integration with renewable energy to power pumps and treatment plants more sustainably. And through global data sharing, we can collaboratively manage rivers that cross borders, tackling floods and droughts as a united front. Predictive hydrology is turning uncertainty into actionable intelligence, safeguarding our communities and ecosystems. With the incredible power of predictive hydrology and AI, we can shift from reacting to water crises to proactively managing them. We can minimize risks, protect our homes and cities, and build true climate resilience that will last for generations to come. Thank you for watching, and don't forget to subscribe for more insights into the future of water.